Hi guys, this is Shrish with experiment number 4 in Unix and Linux Lab. So the name of the experiment is base conversion using shell script, and we have 4 questions, that is basically conversion of decimal to binary, octal and hexadecimal and vice versa. So now let's get on to the program. So what I'm doing here is first I'm running a while loop. Then I'm asking for the type of conversion that they require. I'm taking the option under variable called choice, and I'm running a case, that is switch case, and for each case that is to whatever I'm converting. For each of those cases I'm giving the base value over here. So if you see here, binary is 2, octal is 8, hexadecimal 16, etc. So this is what I have done here. Now what I'm doing here is based on the choice they give. You can see over here, these all are from decimal to a various other type, and this is all from binary to various other type, etc. So I'm just grouping them together. That's what I'm doing here. So what I did is, if choice 1 or choice 2 or choice 3, then I'll give the output as enter the decimal number, and I'll read the input decimal number in A, and while A is greater than 0, what I'll be doing here is I'll be dividing A with whatever the base value that I have assigned over there. Then which is being given to the reminder, and along with that, if since it's if you encounter a hexadecimal value, then in that case, the reminder will be 10. I mean, 10 of about 10, and you know that in hexadecimal, we don't have 10, 11, 12. Instead, we have A, B, C, D, E, F. So that's what we are doing here. We are changing the given 10, 11, 12, etc. to A, B, C, D, E, F. So that's all over here. And if you see over here, I'm displaying the value in uh, reminder and value that is stored in bin, and the value is being stored to bin. Then if you see over here, I'm taking the value that is given, that is A, and I'm dividing with the base, which is um, based on the option that the user has chosen. And then what I'm doing is I'm printing the value that is finally obtained, that is along with reminder and everything else. So you get the value in bin. So I'm printing out the value in bin. I mean the values. Then if you go down, yeah, as I mentioned before, I'm grouping all the stuff. So the next set is binary. So I give an option here for 4, 5, 6. I did similar thing except for the algorithm. There's a change in the type of conversion I did. So yeah, again I'm taking in the binary number and storing it in num. I'm pre-setting two variables p and r as 1 and 0, and based on the algorithm that is provided, um, I'm setting the reminder. That is, if you see over here, the number modulus 10 will give you whatever the reminder is. Um, then that is divided by PC. And similarly, we are doing it over here. The next thing we're doing is printing P, that is the value. Then what we're doing here is, again, if it is a hexadecimal conversion, then you won't be having a 10 to 15. Instead of that, you'll be having A to F. So that's what is going on over here. We are converting the remainder, which is more than 10 and up to 15 to A to F respectively. Then we are merging it and we are printing it over here. The last set is for hexadecimal values. What we're doing here is similar to what we did previously. We are taking in the value. Then if here if you see it is just that one conversion. So for each of them I'm doing it differently. That is decimal, octal and binary, which are 7, 8 and 9. So if you see right here, for the choice is 7, there is a binary conversion, so I base will be 16. And similarly for octal, the I base will be 16, but the O base will be 8. And for binary, I base will be 16 and O base will be 2. Here you don't need to mention O base because the default O base is 10. So you don't have to mention, and when you print the value it will be converted into its respective type. That's just based on what the user chose. So what I've done here is given a already run program. So I have given simple examples over here. I'm doing binary to decimal and decimal to binary. So binary to decimal, let's do with a number that is well known. So 101 is binary decimal for, I mean, is a binary equivalent for decimal value 5. So let's try that. So the option I entered is 4 and binary number I'm giving 101. As you can see over here, value is given as 5. That's just the conversion process. Mhm. Now let's try. Mm, yeah, decimal to binary as I told before. So I'm giving the option enter choice is equal to 1 and I'm entering the decimal number 8. The value is obviously the value is converted to 1000. Similarly, the rest of them also works. So this brings us to the end of the experiment number 4. Thank you for watching.